Steering systems are a critical component in the functioning of any vehicle. They allow drivers to control the direction of the vehicle and ensure safe maneuvering on the road. There are various types of steering systems, each with its own unique components and working mechanisms. Understanding how these systems work can help you diagnose and fix any issues you may be experiencing with your vehicle's steering. So, how does steering work? At the most basic level, a steering system is designed to translate the rotational force of the steering wheel into the movement of your front wheels. This is achievable through several mechanisms depending on the type of steering system. Now, let me show you how your car's steering system saves you effort. This steering wheel here is about 15 inches wide or 380 millimeters in diameter, standard size. When you turn it from full right to left, that's 4 full rotations. The edge of the steering wheel travels nearly 16 feet or 5 meters in total. But during that same motion, the front wheels of your car, the road wheels, only turn enough to move the tire edge about 12 inches, or 300 millimeters. That's a big difference in motion. The steering system is designed to trade distance for force. That means your steering input is being multiplied. If you tried to push the road wheel yourself, you'd need around 16 times more strength. But thanks to gears and levers inside your steering system, it feels effortless. They also ensure that when cornering, the inner front wheel, which has to travel around a tighter curve than the outer one, becomes more sharply angled. Your average car or truck likely utilizes a rack-and-pinion steering system. This simple system is made up of 2 main parts. The rack, a horizontal piece of metal with teeth along the top side, and the pinion gear, a round gear at the end of the steering shaft that interlocks with the teeth of the rack. This is the most common type of steering system used in modern vehicles. When a driver turns the steering wheel, the pinion rotates, engages the rack, and moves it left or right based on the driver's input. The rack connects to the wheels via tie rods and adjusts the wheel angle relative to the car's body. When the rack moves left or right, it pushes the tie rod, leading to the wheel being steered in the desired direction. Consider a driver making a right turn. He rotates the steering wheel clockwise. The pinion gear will rotate correspondingly, pushing the rack gear to the right. The tie rod will transfer the motion to the steering knuckles, which pivot the front wheel and turn them to the right. The number of teeth on the pinion gear will have an impact on your steering as well. Fewer teeth will make it easier to turn the steering wheel, but will require more rotations to complete a sharp turn. More teeth will give you a quicker sharp turn, but will require a bit more strength to complete. This type of steering system is highly efficient, easy to maintain, and provides precise control over the vehicle's direction. BMW was one of the first manufacturers to adopt rack-and-pinion steering systems in the 1930s, with many other European manufacturers following suit. Auto manufacturers in the United States began to use rack-and-pinion steering with the Ford Pinto in 1974. As mentioned, many modern vehicles that make use of rack-and-pinion steering will also be paired with a power steering system. This pairing is known as power-assisted rack-and-pinion steering. This system includes a cylinder and piston located on the rack. The piston is connected to power steering lines on both sides. The lines provide a pathway for power steering fluid to be delivered from a power steering pump located outside of the rack. As you turn your steering wheel, a rotary valve on the power steering pump directs more power steering fluid to that particular side of the piston, which helps ease the steering. When driving in a straight line, the rotary valve will ensure equal amounts of pressure on both sides of the piston. More advanced systems may vary the amount of fluid pressure based on additional factors, such as vehicle speed, turning force, or vehicle load. As a result of the power assist, you are able to turn easier when driving at low speeds, such as when parking, and have greater control when traveling at highway speeds. Older designs use 2 main principles: the worm and sector design and the screw and nut. Both types were enhanced by reducing the friction. For screw and nut, it is the recirculating ball mechanism, which is still found on some trucks and SUVs today. The recirculating ball system accomplishes the same tasks as the rack and pinion system with some key differences. Instead of teeth, the recirculating ball system utilizes a worm gear, a long spiral similar to that of a bolt. This system still has a steering shaft that turns as you rotate the steering wheel, only that the shaft now turns the worm gear instead of a pinion. The worm gear is inserted inside of a metal box with teeth in it. The teeth of the metal block then transfer the motion to a sector gear, a gear which has teeth on only one side. The sector gear then turns a lever known as the pitman arm, which attaches itself to the steering linkage. This linkage is made up of inner and outer tie rods that are connected to the spindles, which complete the turning motion. Inside of the metal block exists many tiny ball bearings. The ball bearings reduce friction between the worm gear and the teeth, as well as eliminate the slack between the bolts and threads. This is where the name recirculating ball comes from. While this type of steering system is less precise than rack and pinion or power steering systems, it is durable and can handle heavy loads. Here are some notable vehicles known for using recirculating ball steering: Jaguar Mark 9, Alvis TE21, Nissan 280ZX, BMW E39 540i, Jeep Wrangler, Ineos Grenadier, and Lada Niva. In the ever-evolving world of automotive engineering, technology has drastically transformed vehicles over the last few decades. Among the numerous advancements that have significantly improved the driving experience is power steering. This critical system not only enhances maneuverability but also increases safety for drivers. So, how it works? At its core, power steering is a mechanical system designed to assist drivers in steering their vehicles with minimal effort. Before the advent of power steering, most vehicles were equipped with non-assisted steering, requiring significant physical strength to maneuver, particularly in tight spaces or during parking. The introduction of power steering marked a pivotal change, allowing for easier handling and improved driver comfort. The history of power steering can be traced back to 1951, when the Chrysler Imperial became the first production car to feature this innovative technology. The immediate benefits were apparent, as drivers found that they could steer with much less effort. This marked the beginning of a new era in automotive design. The two main types are hydraulic power steering and electric power steering. Hydraulic power steering uses a hydraulic pump driven by the engine, providing pressurized fluid to assist steering. A control valve directs the fluid to either side of a piston attached to the steering rack, helping turn the wheels. Conversely, the electric power steering system replaces the hydraulic pump with an electric motor controlled by sensors and an electronic control unit. As a result, the electric motor provides precise torque assistance. Additionally, it is adaptable to driving conditions and speed. Hydraulic power steering assists drivers in steering a vehicle by using pressurized hydraulic fluid to amplify the force applied to the steering wheel. It relies on a pump driven by the engine to generate the hydraulic pressure, which is then used to move a piston in a cylinder, assisting the steering mechanism. It has a cylinder, pump, and a set of valves to control the hydraulic fluid going through them. The pressure is applied through the pump and is driven by a belt that connects to the engine. The pump speed regulates the speed of the engine. Many modern vehicles come equipped with power steering systems, which use hydraulic pressure to make steering easier and more convenient. When the driver turns the steering wheel, this motion is transferred through the steering column. The pinion gear, which is connected to the steering rack, receives this motion. As the steering wheel turns, it also activates the control valve located in the steering gear, usually integrated with the rack and pinion. The control valve detects the direction of the turn and directs the pressurized hydraulic fluid to the correct side of the steering mechanism, left or right, to assist the turn. This hydraulic assistance is bidirectional, meaning it works whether you're turning left or right, ensuring that the system provides help in both directions. The pressurized fluid flows into a steering cylinder, usually attached to the steering rack. Inside the cylinder, there is a piston that moves when the fluid enters under pressure. The pressure from the fluid pushes the piston, which in turn helps move the steering rack with much less effort from the driver. This hydraulic assistance makes the steering much lighter, especially at low speeds, and significantly reduces the effort needed to turn the wheel. After the turn is completed, the control valve directs the hydraulic fluid back into the reservoir. The fluid then returns to its neutral state, ready to assist again on the next turn. The entire cycle is continuous and automatic, ensuring that the hydraulic power steering system operates efficiently throughout the driving process. This continuous cycle keeps the steering smooth, responsive, and easy to handle. The system is designed to adapt instantly to the driver's needs, whether that's requiring assistance for a sharp parking turn or more gradual adjustments at higher speeds. The most eco-friendly and fuel-efficient steering system of them all, electric power steering systems utilize an electric motor that replaces the power steering pump from the traditional power steering system. This electric motor is attached either to the rack-and-pinion assembly or directly onto the steering shaft. By using a variety of sensors, an internal computer senses which direction the driver wants to turn and powers the motor to offer assistance in that direction. The level of assistance can vary based on factors such as vehicle speed and driver input, allowing for a more tailored driving experience. EPS is more efficient than hydraulic power steering, since the electric power steering motor only needs to provide assistance when the steering wheel is turned, whereas the hydraulic pump must run constantly. In EPS, the amount of assistance is easily tunable to the vehicle type, road speed, and driver preference. An added benefit is the elimination of the environmental hazard posed by leakage and disposal of hydraulic power steering fluid. In addition, electrical assistance is not lost when the engine fails or stalls, whereas hydraulic assistance stops working if the engine stops, making the steering doubly heavy, as the driver must now turn not only the very heavy steering, without any help, but also the power assistance system itself. Steer-by-wire is an advanced automotive steering system, where mechanical linkages like the steering column, shaft, and gear are eliminated and replaced with electronic sensors, actuators, and control units. While electric power steering assists the driver by reducing the effort needed to steer, it still relies on a physical and mechanical connection between the steering and the wheels. In contrast, steer-by-wire relies entirely on electronic signals. There's no mechanical fallback unless a backup system is designed in. A vehicle equipped with a steer-by-wire system can be manually controlled by a driver using a steering wheel, which is electronically connected by an ECU. Instead of a traditional mechanical steering column, the rotation of the steering wheel is detected by sensors that measure steering angle and speed. The ECU interpret the driver's input and send electronic commands to steering actuators, which physically turn the wheels side to side, thereby steering the vehicle. The safety of these systems is often ensured through redundancy, which may include multiple input sensors, dual or triple, redundant communication networks and power supplies, and redundant steering actuators per wheel. These redundancies enable the system to maintain functionality even if one component fails, a design principle known as fail operational. In some advanced systems, if steering actuators fail on one or more wheels, the vehicle may be able to partially compensate by using techniques, such as torque vectoring or brake-based yaw control, on the remaining operational wheels. However, this compensation typically supports limited emergency control rather than full steering functionality. Several one-off vehicles and concept vehicles implemented steer-by-wire, such as the early 1990s Saab Prometheus, Mercedes F200, SKF Philo, based on the Opel Zafira, General Motors High-Wire, GM Sequel, Mazda Ryuga, and others. Schaeffler Paravan Technology has supplied steer-by-wire systems for high-performance, one-off racing vehicles, demonstrating the technology's reliability under extreme conditions. Notably, a steer-by-wire Porsche Cayman GT4 competed in the 2020 24 Hours of Nürburgring, finishing second in its class and 29th overall. The following year, a Mercedes-AMG GT3, equipped with the same steer-by-wire system, participated in the race and achieved a 16th overall finish. Tesla Cybertruck, Neo ET9, Infiniti Q50, Toyota BZ4X, Lexus RZ450e, Rolls-Royce Spectre, Lotus Electra, Hummer EV, Silverado EV are the examples of steer-by-wire technology. It's amazing to see how steering has evolved from simple mechanical gears to intelligent sensor-driven systems, enabling safer and more efficient driving. If you found this video helpful, hit that like button, share it with your friends, and subscribe for more automotive videos like this. Leave a comment. Tell me which steering system you find most fascinating or which topic you'd like us to explore next. Thanks for watching. See you on the next one.